Okay, so hello everyone, and thanks for inviting me to give the presentation today. I will start with a disclaimer. I have not actually done much work on Northeast Queensland geology, so my presentation today is not based on a whole lot of new data, but I'm very excited about opportunities for tectonic research in Northeast Queensland, and I intend to start working in this part of the continent soon. So my presentation will be focused on the Big Bend Megafold, which is a name given by Tim Bell for a prominent change in the structural trend in Northeast Queensland. And Tim showed that moving from the Hodgkinson province to the Broken River province and Charters Towers, the structural trend changes from approximately north-south to east-west. In a number of later publications, the same structures has been referred to as the Clark River orocline, or the Charters Towers oroclines, with another extension here into the Anarchy Inlier. But overall, the origin of this orogenic curvature and its implications for the fundamental geodynamics of Eastern Australia and its mineral resources have remained relatively unknown. Earlier publications, particularly from the 1980s, have included some suggestions for the origin of these orogenic curvatures. For example, Harrington argued that the bending was linked to a sinistral movement along the Clark River shear zone. According to his model, this structure was active as a plate boundary, as a transform boundary during the Silurian and early Devonian. Chris Powell suggested that the curvature and strike slip faulting were both related to north-south buckling of the whole fault thrust belt, also the Lachlan orogeny during the Alice Springs orogeny. And Bob Henderson suggested an orogline formation in response to oblique subduction, which first led to a strike slip movement between the Broken River, between the accretionary complex rocks and the four-arc basin rocks of the Broken River province, and the subsequent westward displacement of the western part of that province. Now, personally, I'm very interested in oroclines, and I feel that the Big Bend in Northeast Queensland can tell us something fundamental about the geodynamic evolution of the Australian continent. Why is it important? Because orogenic curvatures are intimately linked to processes of subduction segmentations. Here you can see an example here of an orocline formation in the central Mediterranean. And we can see that the formation of the orocline is ultimately driven by trench retreat, which resulted in tearing and segmentation of the subducting slab, shown here in green. This process could generate tear-related magmatism, which we have recently referred to as SJAM, spatially and geochemically anomalous arc magmatism. It is a process that can be driven by terrain accretion or reed subduction, as shown here in a snapshot from numerical simulations by Moresi et al. And the areas of segmentation and SJAM are empirically linked to clusters of ore deposits. So let's look at the big picture in Northeast Queensland. The shape of the orocline is very clear if we look at the distribution of Neoproterozoic and Cambrian metamorphic rocks. So from the Barnard to Greenville, Charters Towers, and continuing to the Anarchy Inlier. If we look at the spatial distribution of Ordovician rocks, the structure is a little bit more, the outcrops are a little bit more sporadic, but we can still recognize a general trend of the same orogenial structure. Looking at the Silurian and early Devonian granitoids, the shape of the orocline is a little bit different, but we still recognize a sharp bend of the Pama Igneous Association wrapping around the Broken River province and continuing northward to Cape York. Middle and late Devonian igneous rocks are missing in Northeast Queensland, whereas Carboniferous granitoids appear in two major associations, a large blob here of the Kennedy igneous province, as discussed by Robin earlier, and a magmatic arc along the northern New England origin. The important thing is that the orocline is not really reflected in the distribution of Carboniferous granites, and likewise, when we look at early Permian igneous rocks, we don't really recognize any curvatures. We see basically an arrangement along the coast of northeast Queensland. So if we summarize the major conclusions so far, what we see is that the Cambrian to early Devonian tectonic elements are clearly curved, clearly showing an oroclinal structure. We see a period of magmatic lull during the middle and late Devonian. We see a large igneous province in the Carboniferous, and we see that the early Permian magmatic arc is clearly not curved. So the orocline must have formed prior to the Carboniferous and the Permian. So how did the curvature form? One option is that the curvature represents the original shape of the plate boundary, in which case the Chartres Towers province, for example, would form in situ as an east-west structural element. A second option is that sometime during the Devonian, the pre-existing orogenic belt was subjected to oroclinal bending, for example, via trench retreat and slab segmentation. In that case, we'll have block rotations of different tectonic elements, such as the Chartres Towers province. Now, there is very limited amount of data supporting one model or another, but Bob Musgrave pointed out that the declination of Silurian palomagnetic data from the Chartres Towers province is significantly different than the Gondwanan Devonian declinations. So by rotating the trend of the southern limb of the orocline through the difference between the Silurian and Devonian declinations, we get an orientation that is not dissimilar to the east-west orientation of the Chartres Towers province. So based on the limited palomagnetic data, option 2 seems more likely, as it suggests a Devonian vertical axis rotation of the Chartres Towers province. So we seem to deal with a case of an orocline, which likely developed in the Devonian, and at the core of the orocline is the Broken River province, and the question is whether the formation in this area is possibly related to oroclinal bending. And the short answer is probably not. As you can see, the western part of the Broken River province is bounded by two major faults, the Clark River shear zones and the Teddy Mound fault. Now, the whole sedimentary succession, including early Carboniferous units, are folded by northeast-southwest folds, but also by an orthogonal set of large-scale gentle folds, forming dome and basin interference patterns. Importantly, even the youngest intrusions, seal-like microgranites shown here in red and rhyolitic seals shown here in orange, are folded twice, basically indicating that the timing of the formation must be younger than these intrusions that could be late Carboniferous, Permian, or younger. Furthermore, there is clear evidence that the dominant northeast-southwest folding is linked to dextral strike-slip faulting, and I'll show you an example from here, just from the published geological map, the 1 to 100,000 map. We can see a short segmented fault system cutting through Silurian and Devonian units, linked to an arrangement of n-echelon anticlines and synclines. And together that can simply be explained as the result of dextral strike-slip faulting. So indeed, when we go to the Clark River shear zones, we find steeply dipping mylonitic fabrics. You can see the south dipping mylonitic fabrics here, and very clear dextral kinematic indicators. We can see SC structures as well in the mylonitic granites showing dextral kinematics. If we go to the Teddy Mound fault, we find similar type of structures, steeply dipping mylonitic fabrics and the clear dextral kinematic indicators like this nice sigmoid here. So together, the overall deformation in this very broad zone of the Broken River province might represent a transpressional zone, a post-Carboniferous dextral transpression. So in conclusion, the deformation in the Broken River province must be younger than orocline formation. The orocline formed during the Devonian, and considering that a vast area south of the orocline was subjected to basin formation during the early Devonian and perhaps in response to trench retreat, it is possible that the orogenic bending was directly linked to basin formation and trench retreat. One can further speculate that the Devonian magmatism in Charters Towers was partly linked to slab segmentation and tearing, which possibly explaining the east-west structures in Charters Towers, and possibly even linked to a gold mineralization in Charters Towers. The geodynamic processes that led to a magmatic lull in the Devonian and the large igneous province during the Carboniferous remain open questions, great ideas from the Monash group, but we do have evidence that the deformation in the Broken River province is younger than previously thought, and it is ultimately controlled by dextral transpression. So the timing of this large-scale deformation is yet to be determined, but it could possibly be linked to the Hunter-Boyne orogeny, or better known, the Gondwana-Dean orogeny globally that affected the Gondwanan margin during the Permian and Triassic. So thanks for your attention, and I'd like to take this opportunity to thank Rod Holcomb and John Gell, who told me many amazing stories about the geology of Broken River before I was able to visit there myself a few months ago. Thanks a lot.